Hello, hello everyone. Welcome back to the November edition of Serverless Saturdays. Myself Dharmendra, and we have Susit. Hello,
Hello,
Susit.
everyone. Very warm welcome to this month's Serverless Saturdays edition. We have a couple of really exciting sessions lined up for you, and I hope you all have a great learning experience today on a weekend. So, first of all, thank you everyone whoever is joining us across the globe, joining us on a Saturday on a weekend, and we really hope that you have something to take out of these sessions. So yeah, before we get started, I thought we can discuss a couple of things. One is reInvent is coming in just a couple of weeks now. So anybody traveling to reInvent, let us know. I'm traveling, and if anybody's traveling, I'll be really looking forward to catching up with you in person. And and I thought we'll start this month's edition with sharing something that I learned recently. I thought we'll probably try and do this every month that we do. Something that we learn in the last week or last few weeks, you can share it with the rest of the audience as to what you learned, something new. So I was reading about SES, the simple emailing service on AWS. I was trying to understand how we can have multi-region, a better resiliency in terms of sending emails. So as you all know, I work for Confab, and it's an event ticketing platform where we have to send a lot of emails, right? So emailing is a very core functionality of our application. And I was reading about what are the various things that we can do in terms of improving our deliverability, our customers' emails landing in inbox and all those things. And one of the key aspects is you have to verify your identities on ACS, right, to send out emails. And I mean, there was a launch last year, I think probably during reInvent last year, December. There's something called AWS launched deterministic easy DKIM as one of the options for verifying, for identities, wherein you can verify an identity, let's say an email or domain in region A, and you can go to region B. And earlier, if you want to use the same domain or email address, you will have to ACS would create the CNAME record again. You have to go to the domain, add the CNAME record, and get it verified for every region that is present. But with this new feature launch, not really new, about a year back almost, they have made it much more easier to have the same email addresses and domains across different regions, which was a big pain point for us, because whenever we wanted to switch different regions for a particular customer, it was just a big pain. And now, I mean, not now, not recently, but sometime back they've changed it. So I thought I'll share it with you. I'll post a link to the documentation also. If anybody is interested, you can take a look at that. So that's a small thing that I learned recently. And if you have something that you have learned recently that you would like to share with others, please do so in the chat. Yep. So yeah, Dharmendra, I think we can get started. You can introduce the first speaker.
Yes. So this time, yeah, we have two speakers for this session, and the first session we have from Luis. He is joining us from Peru. So, Sasit, if you can add him, and
Yeah.
he is joining midnight. Uh, and he's totally fine. So that's pretty amazing. Hello, Luis. How are you?
Hello, hello, Dharmendra and Susie. I'm very happy to be with you and to share the things that I have learned in this talk. So thank you a lot.
Okay, thank you, Luis, for joining us. And I'm pretty excited for your session, and hope our audience will also love and learn from your session.
Yeah. Over to you, Louis. You can share your screen, and you can get started.
Maybe a moment, please.
Yes.
Okay, my talk is called Serverless Media Workflow for Fast Channel using AWS Elemental Media Services. a question that I always make in these talks is about, do any one of you have heard about these services? I think maybe there are some less than 10 people that know about this, because these services are not very popular as Lambda, EC2, Compute, database, and so on, because they are used specifically for certain cases. For example, for OTT services, for apps like Pluto, Tubi, or even Netflix. Use it. So I'm going to explain about these services, and then I'm going to show you a small demo that you can follow, and it's all with Lambda, SQS, and EventBridge. So let's get started. First of all, I want to present myself. My name is Luis Valdivia. I have four AWS certifications. I work as a CTO here in Peru in a local company called Plus One Design and Development. I'm also a community builder. This is my second year. I have more than 15 years of experience in software development. I have 2 master's degrees, one in project management, and the second one is an MBA with focus on technology. I'm also a PhD candidate in education, and I also work as a university part-time lecturer. As you can see, I'm a very big fan of John Cena. You can see me. So the agenda, I'm going to explain some key concepts to understand this word, because there are some strange words that we are going to learn. Then I'm going to explain these services of the media service family. Then I'm going to show an architecture that you can deploy, an example, and then I'm going to explain more examples about this. First of all, I want to explain what is HLS. HLS is a protocol that was developed by Apple for delivering audio and video over the internet, primarily used for both live and on-demand streaming. When you open Netflix app, Prime app, or Crunchyroll app, you go to the home screen and you go to the series or content that you want to play, and you play that content. As many of us know, if I record a video on my Android device or even in my Apple device, the formats are very different. So how is possible to these apps to play these videos in a universal format? This process is done by this protocol that is HLS. So what is the second term that we are going to use? VOD, video on demand. This is a media distribution system that allows users to access video content wherever they choose. The typical example when we watch VOD content is on YouTube. If you search for a Python tutorial to become a super ninja, you start the video has a duration, that video is VOD. Even Netflix, Prime, Crunchyroll has VOD. So you can watch the content every time that you want, and it doesn't follow a programming grid. What is a programming grid? Is like a schedule where you can watch certain videos in that specific time. The third one, what is a fast TV channel? A fast TV channel is a free streaming service where users watch content following a programming grid accompanied by advertising. Typical apps that are fast TV, Pluto TV, that is very popular here in South America, and there is another popular that is called Tubi. Or even if you are a LG, if you have LG TVs at your homes, these TV apps have some fast TV channels. You can deploy fast TV channels using AWS. The last concept, what is a playlist? A playlist is a file that has a weird extension that ends with MPU8, which is like a text file that contains some certain logic. For example, if you are watching a series on YouTube, on Netflix, if you have a very good connection, internet connection, the content will play very good. You will see all the details, and even if you have a satellite or a very good connection, you will see all the details, and you will see, even you will watch it even on 4K, 8K, or 16K. But if your internet connection is not so good, you will see the content, but the quality will decrease. And if you have a very poor connection, you will watch your content in a very bad quality. Maybe many of us have a programming background, and you will say to me, Luis, that is built using a conditional statement. Yes, it's a conditional statement that you detect that your internet connection, and based on your internet connection, it will show you certain videos. But that to do that, you don't need to know any programming language. You can do it with following a wizard, and I will explain this in a few moments. So this MTU files is a text file, but when you process your video and you convert that in a universal format to play it everywhere, these videos you split the videos in a very small files with extension called TS. The TS are linked to this playlist that is the MTU file. So the MTU file is like a heart or all the streaming. If you watch Netflix, Prime, Crunchyroll, a playlist exists, even if they're streaming live or maybe in a fast TV. So I'm going to explain here the media service, as I mentioned before. If I ask you about EC2, RDS, Lambda, maybe all the audience will tell me what these services are. But if I show you this logo, AWS Elemental Media Live, I don't think all the audience can answer this question. Maybe the only one that know about these services is me. So AWS Elemental Media Live is a service where you can deploy a live TV channel in just minutes. You only have to follow a wizard, and you need an input. An input, it could be this cell phone, a camera, an encoder, or any other thing that you need to have. Popular companies that are using this: Netflix. As I mentioned before, I'm a very big fan of WWE wrestling, and many of you that maybe don't know that Netflix has signed a multi-billion-dollar contract with WWE to stream all its programs and all its live events. So they use Media Live. And there are very popular channels in Japan, Europe, and in United States that use it. If you are a very big fan of NFL use this. If you watch Formula One, it uses Media Live. And even if you are a soccer fan that likes the Bundesliga use this service to stream all its matches. Second service that we have, AWS Elemental Media Package. Media Package is like a brother to Media Live. Media Package has some qualities that Media Live doesn't have. Media Package, its labor is to transform the videos to deliver it to multiple formats like HLS, Dash, and any other format. And it also have two very important characteristics or features. One feature is that Elemental Media Package allows you to control your live streaming. What is that? What is this meaning? For example, you turn on your TV and you start to watch Netflix, and maybe there is a pay-per-view of WWE called Backlash that starts around 1 a.m. and you enter the app 1 a.m., 1:30 or 1:15, it depends on the time. And you start playing, and it'll show you a pop-up that says, do you want to play it live or do you want to play it from the beginning? So if you select play from the beginning, you can control your live stream and you can go to the past. Media package allows you to control your live streaming to go to the past. You can go to the future because the future doesn't exist. You can go to the past, and even you can go to the past until 14 days. And the second feature that is very interesting is, as many of us know, if I open a browser tab and I start to navigate to a website, I can right-click, open developer tools, network section, and I can see all the requests, all the files, and all the asset that is loading, right? And if I double click and open in another browser, I can download it and I can use it as I like. To prevent this, because if you try to do this on Netflix, you can, or even in Prime, Crunchyroll, or the other streaming app that you use. You can, because they have a feature called DRM. DRM is like a key. With this key, I only allow to play my content in section or apps that have the other key. If both keys match, the content is played. If both keys don't match, they won't be played. So media package allows that. The third one that we are going to use in this demo, media tailor. Media tailor has two important features. The first one is to play ads. If you go to YouTube and you look for a tutorial about AWS services or anything that you want, you start playing, and it shows you sometimes ads at the beginning of the video, and the middle of the video, or even at the end. That is handled by a service called Ad Decision Server. The Ad Decision Server sends information that you have to process on your video, and it allows you to watch the ad at the start, middle, and the end. This feature is handled in AWS with Elemental Media Tailor. You only have to sign a deal with an ad decision server. You make some configuration, and Media Tailor will do it. You don't have to create a Lambda, make some crazy things, or maybe learn a new programming language. You only have to make the connection and wait. And the second one that is very used for fast channels is something called channel assembly. With channel assembly, you can create like a timeline. In this timeline, you can add VOD videos. And when you start this service, it will look like it's like a live streaming channel, like Pluto or Tubi, but it's built based on VOD content. Now we have Media Convert. As I mentioned before, we have these popular apps convert the videos that they have in a universal format. We can do it. There is a very popular command on Linux that you can use that is called ffmpeg, which is very popular. You can use it, but the main disadvantage that has this command is that you have to install it on an EC2 and on a Ubuntu operating system. And it consumes a lot of processor and memory. So you have to increase the machine, or maybe you have to give them support. And as many of us know, we know that EC2 and AWS depreciate these instances, so we have to take care of that. With Media Convert, you only have to work with one thing. You have to create like a recipe, which is a job template when you specify all the qualities that you need to have. If you go to YouTube, you can watch your content in good quality, medium quality, bad quality. All the things it's handled by Media Convert. You only have to make this recipe, and the recipe will upload it. You put your origin video and then your destination. You only have to wait, and it will work very fast. You don't have to install anything. You don't have to deploy on EC2 or make some customization. You only have to wait. And the last one, that is Media Connect. Media Connect is a service that you can use when you are working with cable providers. Cable providers, the only language that they know is to work with satellites. But the main problem that satellites are very expensive. You can hire a satellite, but it's very expensive. I don't know if your credit card will allow it. You can. With AWS Media Connect, you can establish a secure connection between your channel and the cable provider. You don't have to learn any of the crazy protocols, because cable providers also work with crazy protocols that we don't know, and we don't have to know it, because we only care about HLS, BOD, RTMP, or any other protocols that we work on a regular basis. So with Media Connect, it allows this. It establishes this secure connection, and you only have to send it, and the cable provider will stream your TV to your TV channel or the app that you're using. So with that, we have talked about all the media services that we have. There are a few more, but they are not relevant in this talk. The architecture we are going to use, or we're going to deploy. We can see that we have an S3 bucket, and we can configure an event to send it to a Lambda that is written on Python. Then this Lambda is going to send this to Elemental Media Convert after it sends it to an S3. This Elemental Media Convert will send it to Amazon Event Bridge. This Event Bridge will send it to AWS Lambda, and this Lambda is going to send it to a source location. When you are working with Media Tailor, you need to create a source location. A source location is the place where you link your videos to Tailor. After you process your videos, you will send it to Tailor. So I'm going to show my console. One moment, please. One thing that I forgot to mention is this is a repository that I have created where you can follow where the code is uploaded, and this is a small player that you can scan, and you will watch some content that I am streaming. If you try to scan it, this content is already streaming because I have configured it before this talk started, but you can scan it and you will see that I'm streaming Blue Lock. I will show you how to do that. So let's go to our console. I'm going to my console, and if you check the first QR, I will show you later. It has some templates, some policies, and 2 Python scripts. At first, we are going to go to Media Convert. And here. In the first part of my architecture, I need an S3. As many of you know, with S3 you can dispatch events. I have configured an event here that is called process video. With process video, if you want to edit it, I have configured that only the files that are stored in the folder called videos and with extension MP4, it will dispatch these events, all create events. That is pointing to a Lambda. This Lambda, in my case, is called process video. If you want to, I will show you what this Lambda does. It will be called process video. As I mentioned before, it's written in Python. I like Python. Here we have some dependencies, and I have configured 3 environmental variables: a media convert role, a template bucket, and a template key. I have import Boto3, and let's check this code. Here is, I have, with this event, you can detect if a file is uploaded, you detect it, you can check the name, you can make some configuration to clean it, or to do some other validation that you want. Here is a validation that if it's not with videos, I will not upload it. I have created a unique name. I have created where is my input, where it's going to put it after it processes. The template, as I mentioned, you work with a template. This Lambda is going to make 2 things. It's going to detect if the video is uploaded, and then it will transform it and send it to media convert. And media convert is the one that is going to convert it to this universal format that we can reproduce or play in our devices. This is, I change that is going to be the input, and this is going to be the output. I call the method that is create job, because media convert works with jobs. You configure some tasks, and this task converts to jobs. So I'm going to show here the job template. This job template is a JSON file. It doesn't have anything weird. I'm not doing some crazy things. I'm not going to install a malware on your device. But this is a very simple JSON file. What is important in this JSON file? The qualities. I'm converting this video on 3 qualities. This one, the second one, and the third one. If you want more qualities, you can change this template, and you can create the other one that you want. You only need to know the width and the height that you want to transform. And that must be way that you can work it with Amazon Q, or maybe with ChatGPT. Then this is where I want to generate the output of my video. And then we are going to make this on live. So I'm going to upload a video and show you how this magic works. But before this, I'm going to go to media convert. Media convert, you can type it here, media convert, and it will send you to the section of this service. And you need to go this loading, and we go to jobs. Every job that you send is going to be listed here. You are going to see 3 status: pending, processing, complete. If something is wrong with your video, or maybe with your configuration, it will show you error. And in the error, you can check that is the reason of the error. Maybe your bucket is not public, you have not created the correct policy, and so on and so on. So I'm going to upload the video. I'm going to upload a small video to show you this process. So we go to my bucket, go to my folder that is videos. I'm going to look for a video. One moment, please. I'm going to change the name. I'm going to upload it. My video is called Dan 6. Upload it. It's uploading. We have to wait some minutes, some seconds. It has finished. So we go to jobs. We refresh the screen and it's already on progressing. This video is very small. I think it's around 20 seconds. And if you click on the detail, you will see that it's going to show you all the work that it's doing. In this case, it finished in around 1 second, and it has created the 3 qualities. I store these qualities in the same bucket that I use. So if you go to here, you can watch that it has created the TS file that I mentioned, and also it has created some file called NTU8. If you want to check what are these files, it will create all these TS and it will create NTU files depending of the qualities. If I have 3 qualities, it will create 3 NTU files, but it will create an additional one that is the main of this, the heart. The heart is this one. That is the main one. If I want to open it, I'm going to open it. Let's download it first. Let's download. I will download it maybe in. I have an extension. Let's open it here. No, this. I will open another browser because I have an extension that allows me to do this, allows me to play the video, and I don't want to play the video. I will open it here. Here it has downloaded a file called NTUA. I will open it. And it has created this. You only follow a tutorial with me, and you didn't have to learn any programming language. Do you have to implement any switch statement, conditional statement? I don't think so. We have created this following a wizard and following the template that I have used. And it shows you all the qualities that we have implemented. So you don't have to do anything and install anything weird. Now, let's see all the other things. To make this example work, you are using a Lambda. This is a Lambda file. If I go to my section of Lambdas, I have 2 Lambdas, the source location and the process video. The one that I showed you before is process video. It's loading. It's loading. One moment, please. Here is my code. It's the same that I showed you in Visual Studio Code. And you have to make some customization, because if you want to make your Lambda work with another services, you have to attach policies. So if I go here, I will go to permission. I will open my execution role. My execution role has a custom policy that is here that allows him to create jobs, to get the object for the S3, to make possible to put objects inside my new folder called convert, and I also need to allow him to go to my bucket where is my template. My template is located on a bucket. It's the same. This template that I show you here, I put it on a bucket to allow the Lambda to read it. And then we need to configure a specific role for media convert. This specific role is called, in my case, media convert role. If I look for it, it has a custom policy where it allows him to read files, to write the files inside a folder, and it also to create logs to check on CloudWatch if we make some mistakes. Where is this policy? In the folder, in the repo, there is a folder called policy, and here is the media convert policy, and also the process video policy. You only need to attach it, copy, paste it, and attach it, and this Lambda will work. Now, we are at the middle of our architecture. We are here. How we send it to Media Tailor? To start working with Media Tailor, you need to create a channel. Media Tailor. You need to create a channel. I have already created a channel where is the content that you are playing. If you want to create a channel, you will need to create channel. Let's put it a name, test, for example, and there is two types, basic and standard. The one that is with basic, you can create like a list timeline where you put your VOD contents, but with basic, you can create this timeline with VODs that you have on your S3 buckets, and also you can add it live signals that, for example, your provider send it, or you are sending a live event. You can mix both of them. If you only want to do VOD, this is my case, you need to do standard. And here you decide what you are going to show. In programming, programs don't have a specific duration. Maybe some of them takes more time and the others take less. You need always something called filler state. A filler state is like a small content that you are going to show when you don't have content. In this case, you can select it from a source location. What is a source location? A source location is like a folder where you map all the content that you have on your S3 bucket to use it on Media Tailor. This is this part. I have already created a source location, but if you want to create a new one, the only thing that you need is a name, for example, test, and then a base URL. This is an S3 bucket, and we know that the S3 works very, very, very good with what? With a CloudFront distribution. I have already created this CloudFront distribution that is pointing to my S3 bucket. I click on create source location. Is very fast, and then we start to add it, all this content to a source location. But this is going to be done by our Lambda. We have a second Lambda. In our second Lambda, here is our second Lambda is called source location. Source location, what it does, it is loading source location, source location, source location. In this case, it's the same. Some dependencies we call Boto3. In Boto3, we are going to use Media Tailor. With Media Tailor, we are going to detect the event that is going to send us Media Tailor. Media Convert. Media Tailor is going to send us an event, and we are going to listen here. We are going to listen the event. We are sending the folder that we have already converted, and with this we only send it to create a source location. If you don't want to do this using this Lambda, you can do it manually. And manually, you do it by doing this. Source location, BOD, add source location, add BOD source, add name, for example, this one, and a path. This is the relative path, not all the full path, the relative path. In this case, we're going to say this folder, content. We click it, and it's already there. As you remember, I have sent a video, and this video, it was already converted, but this has an attached some an event bridge, because if you remember our architecture, we have these buckets, the lambda that I showed you, the media convert, the second lambda, and the source location. We need Amazon S3 because elemental media convert, you can send that event to a lambda directly. You need event bridge. Event bridge will listen that event, and with event bridge, then you can send it to a lambda. So if we go to event bridge, we open event bridge, and we go to rules. And in rules, I have a specific rule that is going to listen the event from media convert, and then is going to send it to a lambda. Here it is. This is my source location, and the destination is the lambda that I showed you in a few seconds ago. So if we go to our our media convert section, I'm going to copy the IDs. If I go here, my ID is this one. We start with 8. I go to our video source, and here it is. Our two lambdas work together and works fine. We have uploaded our video. We have transformed our video with media convert. Then media convert, when it finishes, it sends it automatically to media tailor as a video source location. Then if you want to use the source location, you can create, for example, a new channel, as I was doing with this. I'm going to use standard, and here I'm going to put it as slave. Slave is like as I mentioned, is if your content is not exactly, you can put a small video that is going to loop every time that a new video starts. So I'm going to select VOD, and I'm going to set this loop. Loop is a video that I use for these cases. Here, if you want to configure some audiences to track them, you can do it here. In this example, we are going to do that. Here, we need to put a name to the manifest. What is the manifest? The manifest is, we have the entry UI files that all the video has, but when you use Tailor creates its own entry UI files. So you have to give it a name. You can put it index, game, playlist, or anything that you want. I'm going to leave it as index. You can use HLS or dash. In this case, we are going to use HLS because it's the most popular and the most common that is used. A name that you can use to group all your content. Next, we have to attach a public policy to allow this to play it. And next, and create channel. We only have to wait some seconds. And then if we want to start this content, start. This channel is empty, but it's already added this slate. If you want to test what is playing, we go to outputs, we copy this URL, we open a browser, we play, and it's going to show this. In this case, this is my slate. It's like a little frog that is playing around. If we go to our channels again, I have this one that is India Meetup. I go here and it's already showing a program. That is, for example, a small segment of WWE. If I want to add another program, I go to Add Program. I place the name. I'm going to use this. I'm going to use log. I select after what program it has to start. I say program 11. Next, next, next. All these things that I'm doing manually, you can do it using the SDK or AWS CLI. I'm showing this with a console to explain you all the process and how it works. Because you can do this by SDK or CLA. At my production environments, I do this with with CLA. I don't do it manually because we have 24/7 program, we're 24/7 channels, and the programming grid is very, very big. So I'm not going to do that all the days of my life. So in this example, I'm using manually to explain you, but you can do it with the things that I mentioned. As you can see, we have all this process that is used with Lambda. I didn't have to create an EC2, RDS. Maybe if I want to track all the process, or if there is errors, maybe I will use an RDS or maybe a DynamoDB. Or I can make some more customization or validation of my lambdas. Because if you check both of my lambdas, leaving behind that we are using these crazy services, both of my lambdas are very simple, because the first one is listening that if a new object is put it on the bucket, is put it on the bucket, it's going to create a unique ID, then create some destination routes, and that's it. I'm not doing any crazy thing with machine learning, generative AI, or other thing that you do. And the second one, if you leave behind, you leave aside, if you leave aside the thing that we are sending to Taylor, to AWS Media Taylor, is only listening that something has ended and it has to do other thing. As I mentioned, a very simple lambda. A very simple lambda that is only listening events and doing something. It could be a conditional statement, sending a SMS, sending a email as was mentioned some minutes before this presentation. So you can do everything, and these lambdas are very simple. You can check it on the repo. I will show my QR again. This is the QR of the repo. I will add some instructions, because I finished this repo around 30 minutes before the meeting. So sorry for that. And because at my country is around 1 a.m. And sorry for that. And this is the play. My play is going to be showing this stream around a few more hours until it ends, but you can play with that. So I will show my presentation again. One moment, please. Tenemos. As we were talking about, this is the Yes, sorry, I forgot that I wasn't sharing. As we were in this example, I show you how to deploy this architecture with the lambdas, with the IAM policies. And this is like a small fragment of what these big companies like Pluto, Tubi, LD channels are using. They put VOD contents as if they were live videos. If you use Tubi Pluto, you can check it. We have uploaded some videos. It was transformed and then it was sent to source location to play it with media tailor. In this section, we didn't have to learn some programming. We didn't have to install the crazy command that I said. And maybe some of you know about WOWSA, WOWZA. WOWSA is the titan of streaming. In this example, we didn't have to install it. We only follow a wizard, and this wizard of the services are serverless. You didn't have to deploy EC2s, RDS, cluster, or any other things. And these are configured with events on S3 and the events of media converts. So it's very easy that you can test it, make some errors, make some crazy customization, and maybe you can deploy some cool things that we can test. I go to this one. This is the repo. This is the player. This is the player that you are scanning. As I told you before, is streaming again. Is sending blue log in this case. I will upload some more videos that you can play and see and watch later on. And that's all. Thanks a lot. This is, as I mentioned before, I'm a very big fan of John Cena. This is his last run at WWE. So thanks a lot for your time, for your patience. And if you want to connect with me, this is my QR. These are all my social medias. And there is I launched a small YouTube channel. If you like this presentation, I will appreciate a lot if you follow me on my YouTube channel. You like my videos, but there is a small problem. My videos are in Spanish. So if you want to play my videos, you have to activate the subtitle. So thanks a lot. And if you have any question, doubts, or spoiler that you want to talk about, you can leave it on the chat and I will try to answer it. So thanks a lot again.
Thank you so much, Luis, for taking the session. I mean, first of all, for me, I mean, I've heard about these services, but only because they are on the AWS console. When you search for something, these start coming up, and that's pretty much it. That's my knowledge about these services. But really interesting to learn about how Netflix and all these other streaming companies, especially video on demand, use it, and really wonderful to see the live demo part that you showed. I'm sure people really loved your session. I don't think we have any questions at this point. But first of all, thank you so much, Luis, for joining us so late in the night for you. We really do appreciate you taking time to share your expertise with our audience. And it was really a wonderful session. I did get to learn a few things that I was not aware of. Thank you so much for that, Luis.
Thanks to you, because as I mentioned before, if we prepare for the 12th certification of AWS, in the 12th certification, they don't mention these services. Or if they mention it, it's a very small, it's only a sentence that you say, with Media Live, you can deploy a TV channel. With Media Convert, you can convert, and so on, and that's it. If you want to do it, you have to look for tutorials, ask architects, and maybe to test, to try and error. That is.
Yep, wonderful. Cool. Thank you so much, Luis.
Thank you.
Yeah, I'm really looking
Thank you.
forward to having you again in the near future.
Thank you.
Okay, so moving ahead, that was a great talk from Lois, and now we have our second speaker. Uh, as you all know that Bharath joining us, and he is working as a engineering manager at Azuga. Hello, Bharath. How are you?
Hi everyone. Hi Susheth. Hi Taran.
Hey, Bharat, finally got you on the stream. I've been planning for this, and for folks, I mean, Dharmendra, Bharat, and I used to work together in office pre-COVID.
Yeah.
So yeah, it was really fun working with all of these guys, and yeah, I mean, I've worked with Bharat at various capacities in different things. Wonderful, wonderful engineer. I mean, he does so many things. He's a civil engineer. I don't know, Bharat. Come on, you should introduce yourself with all those things that you do.
Yeah. I mean, I'm a graduate of civil engineer, but my passion is now in development. And Susheth was the one who introduced me to serverless technology. So I've learned a lot from him, from Dharam as well, while we are working together. And I've been following their work as well offline around AWS and others.
Awesome, awesome. So the stage is yours, Bharat. Really looking forward to your session.
Yes. Thank you. I'll start. Share my screen.
Yep. Yeah, you're good.
Okay. So today I'll be talking about agentic architecture, mostly how to build serverless agents, how we could connect with the serverless agent, what would be in a way to save the context, save the memory, and also use some of the tools and demonstrate how we could build incrementally on AWS with the cloud native services. So, I mean, I think this agentic architecture or agent in itself has been the buzzword in the last couple of years. Cloud native solutions was, the other buzzword that was there before the agentic architecture took over. But if you combine these two, you get very scalable, intelligent workflow that you do not have to code everything end to end, right? Not in a deterministic way. We can use a lot of services available that will help us to build these aspects to complete the workflow, to get the work done without having to have everything added to these services. In this session, mostly I'll be going with how to use Strands to build the agent, what capabilities it can have, how to extend that capability. We'll start with very simple example, then we'll start building a more complex in terms of saving the memory, saving the context of it. And using cloud native, one, it provides a holistic approach overall in terms of its scalability, uh, also cost efficiency, management of these services, uh, and providing that end-to-end developer experience, not just building the workflow, but also managing it and maintaining it as well. About me, I'm like I mentioned earlier, I'm graduate of civil engineering, but moved into software. Got introduced into serverless technology while working with Sushrit, Dharam, and others. And I've been working with Azuga now. Azuga is a fleet telematics company. We harness the power of GPS to provide holistic fleet telematics solutions, and our core proposition within it is the fleet safety and driver coaching and driver reward. Uh, In Azuga, I've been working across multiple aspects, working on cloud native solutions, driving the tech stack modernization. We've worked across monolith, microservices, serverless. We've moved all the way to serverless now as well. Uh, and many of our colleagues are hands-on with serverless and hands-on with serverless patterns. They're all very passionate about the new technologies that comes in, and most eager to try out the new technologies and build new workflows using those new technologies. So what we're going to build today is a travel decision agent, or more like a travel planner. So I want to know where, I mean, let's say I want to travel to Delhi or Bangalore or from Mumbai. I want to know what's the weather like and how many flights I have today to travel there, right? It's a very simple workflow, a bit of deterministic, bit of non-deterministic there, but mostly sticking to that simple workflow where I ask a question on uh, what's the weather like, and can you recommend if I should travel there or not on a certain period of time, and what flight do I have there, right? And we see how the how Strands as a framework will help us to build the agent, and how we can deploy it on the Lambda, and how we could connect to it, and what are the other ways that intelligent workflows can be built around it, right? Taking a step back on Strands is a agentic architecture framework which helps in building agents. It can be deployed on serverless tech stack, or it can be deployed as a server full tech stack as well. But it also has, given that it is open source from AWS, it has very close native integrations with a lot of AWS services provided in AWS. So let me jump directly to the code. So we're going to see 4 examples. One example is just simple agent, and it takes question, gives me an answer. We deploy it behind a gateway. We hit the gateway, we get the same answer, and we see how it works, right? And from there, we'll keep on adding more and more variations to the same problem statement. So if I see here, this one page is its entire agent, and it's working on it. There's no other there's no any other code. There's no anything else, and that's the beauty of the Strands, where one simple creation of agent, you're ready to go. Of course, the more complex it is, the more necessary tools and context has to be provided, but it's so simple that it's just one single file which does the job, right? So I'm using OpenAI model. Again, the Strands has interfaces which you can using which you can use your own model, or you can use OpenAI, or you can use Bedrock and others as well. So just going through the code, basically you get a request on the.
Bharat, sorry to interrupt. I think we're still seeing your presentation. Are you sure? Yeah.
Sorry about that. You're able to see my code now, the visual code?
Yes. Can you please increase the font?
Yes.
Yes, I think perfect. Thank you.
So yeah, like I was saying that this one single file has everything within it for it to work for this workflow, right? Given date, time, and travel destination, I get my recommendation of whether to travel or not to travel, right? And like I was saying, Strand provides you models with interfaces to connect with the different models, where providing the key, we can start connecting to it. You can, given that Bedrock and is other native to AWS, it has very direct Bedrock. The interface is directly available on the Strands. It doesn't have to be like you have to create a model and then provide for Bedrock. But I'm using OpenAI at this point. We have two tools where there is a weather tool which will get me weather. There's a tool which will get me the flights from departure and arrival. Let's take a look at the system prompt. System prompt is the one that helps us that helps the agent to know what to do given the prompt from the user, right? So if you see, this is the system prompt. Basically, it is helping us. It will take the flying cities, takes the origin and destination, travel time, calls the tool and calls the weather tool, decide if there is flight delayed or chances of rain or anything, then it will tell us no, don't go, or travel, or maybe travel, right? And we'll also see how these tools are called, what happens if there is an error, uh, what are the events that are being generated while the agent is figuring out what to do next. So now I have deployed this. I'll just go through the deployed version of it. So it's behind the gateway. So hitting the API, we should be able to get the information from it. So it's the same code that we just saw. So let me trigger the API call. So here I want to travel from Bangalore to Delhi. What do you recommend, right, on today? I hope it works. Did not. Okay. I think it's a different API. This is the one that the simple implementation of the planner. Okay. So we see a recommendation. It says, yes, there are 20 flights from Delhi to Bangalore. Most of them, 15 have already landed, with 4 currently active and 1 scheduled. So it gave me a suggestion. It gave me recommendation and how many flights are there. It's a good day for traveling. It's clear weather. Actually, there's clear weather. There's no rain or anything at this point, right? So let's go back and check on the execution of this aspect, right? So if you see, this was my query, and I got recommendation of yes, and I got a response from there. So the only thing that we got as a response is from here till here, right? But the agent was calling the tool, calling the weather tool, and trying to figure out what it needs to do and all of that, right? So that's the next phase where we'll see how to extract all the events that the agent is internally trying to figure out to do on the to get to the recommendation stage, right? To decide on the recommendation. Okay, going back here. So so Strands provides ability to stream the events that is happening within the agent whenever it's being triggered in that sense, right? Let's say the same question is being asked. So with streaming of the events within the agentic loop, you can understand what the agent is trying to decide and how it's triggering the entire uh, aspect of it. So here we have, it's a similar workflow. It's the same prompt, same tool, same AI, same model being used. No change. The only change is now that we are trying to extract more information of how you're planning, so how you're thinking, and what were the steps taken while you were thinking to execute uh, the uh, the given prompt in this case. Right? So if I go here, so you can see that we can see that there are events coming in from the agents. There are data events. There is event from how many counts of event have come in. What is the query is passed to the agent, and from there on you can see the entire things that the agent will do. It will give us an output of all of that. So let me run this locally first. So as per the output, we can see that the agent is deciding on the number of and the on the events and what needs to be put out uh, as an output from the agent and what can be used to show in the UI as well. So every aspect is being put out here, and we can see that what data it is, the tool usage as well, and so on. So there were in total there were about 300 events before it actually decided on the recommendation of what it needs to do. Right? These events are nothing but it's agent trying to figure out what uh, given the prompt, what it needs to do to get to this recommendation. So the final result is after 356 events of internal looping with the agent. Right. So we got the response here. Now this is again trying to get more insights from the agent, trying to understand how it's working and what exactly it's doing within the under the hood, before getting just the final output. Uh, but let me show what I mean. In this case, I've asked for I want to travel Bangalore to Delhi, and it gave me the recommendation. But if I change I got to know what the agent is doing under the hood as well. But let's say I want to continue the conversation and say ask again how many flights are there from Delhi. So I think there's some memory context being held. But yeah, in this case, there's no session being held. So most likely the agent will not have the context of what was previously spoken. Again, this is running in the same session, so most likely this is having the context of it. But if this was a new session without any previous context of it, it would ask for more details in that case. Yes. Or maybe let me change this. Okay. And then from Bangalore. Okay. So yeah, some context is being held there, but we don't have any messages or reference of that as as a memory context within the system. Now to store that, what we can do next is we can add um, memory to the agent now. So that's the next step that we will do. So one is we saw a simple question and answers. Then we are seeing the streaming of it, wherein we see the entire loop of the agent and what it does behind the scenes. Next is let's look at the memory aspect of it. So Strands also provides memory that could be, that is out of the box. Basically, it's a S3 session manager. Uh, you can store all your sessions within S3, and it doesn't require a lot of any additional code or anything. It's just a simple S3 session manager initializing it. What should be the session ID and the prefix to it, and we get the entire session stored within the S3. Right. So let me start with that. So the handler is again same. We initialize the session if there is no session, and if the session is available, then it will start continuing adding to the same session. If the session is not available, it will create a new session and give us the session context there. So what this additional two things that we have added to the agent is these two lines, that is conversation manager and session manager. So conversation manager, it keeps the context window, the sliding window, how many messages I have to go back and how many messages I have to go forward to get the context for the agent. All right, that's the conversation manager. Session manager is, it decides to log at different stages within the session what has happened, and from a point of view of the agent, also from the point of view of the user as well. So let's see this. This is also deployed. I can show that. Okay. So same architecture in that sense. It's behind a gateway. We invoke it. The session planner and the session manager will figure out how to make an entry into the S3 and when to retrieve it, how to retrieve it, how much to add it into the system, right? So let's start invoking this. If I do, I just want to test it again. Okay. Cool. So this is the memory one. There's a session ID here. Let me start a new session and see how this works. Right. Let me just hit this query. Yeah. So right now the context is very clean. There is no context available within the agent. So it's asking me to provide more information, which is what will happen even in this API case. At this stage, there is some cache that's playing here, but in a real world where you are invoking these queries at different stages, right? It's not at the same stage. It could be a different phase. The context may not be retained in the cache at that point of time. So you need a place where you can store the memory and retrieve the memory at a later point using any of the storage mechanism, right? So at this stage, it's asking me to provide destination and others, right? So I'll provide the same query. Okay, we see that there's an additional parameter here that's being passed from the system. That's session ID. So there's a session ID created now. So let's take a look at it as well from the system point of view as well. So if I go to CloudWatch, so I can see that it's exactly same query. So mostly it took the same path. It gave me the recommendation, and we have the recommendation here. Let's go to S3 and see if that session is created. Let me see the session ID 59E18. 59E18. Right. So you can see that there are number of messages here. So going to each, I can see that this was my query, and let me go to the next one. Now you can see the tool use that the assistant has done, right? What tool did he use? So he used, the agent used two tools here, flight and weather call. So these were not the parameters that we give. It extracted from the query that we provided to it. So this is very this is where it becomes non-deterministic, right? We don't necessarily have a cleared set path line to for it to do all these aspects. So, and if you go back, we can see more and more messages. I mean, exactly how it arrived at the final response. So these are the response that we got from the tool, and once it received the response, then it created the final message. Right. So right now it's on S3. Given that natively the Strands has a manager, has a class manager which helps to store the session within the S3. Now let's also pass this session and see what happens next, right? We pass the session and we will change the weather in Bangalore. Okay, so it gave me a response. We'll look at this one as well. So now I see there are more being added to this. Like this is the response that we got from the agent. You can get more insights from on Bangalore weather. Okay, so yeah, I can see there are more. Let me go to one of them. So this is my query. And so in the first use case, it queried two things, right? It queried on flight as well as weather tool. But in the second case, it did not go through the flight query because there was no need of querying it. So the agent is thinking on when to use the tool and when not to use the tool as well, right? So it's thinking that, okay, for this sort of a query, I don't have to use flight. I can just use weather tool and get the response from it. So it got the response and then it created a response for the user uh, in that sense. The next thing that I want to show is, so given that now it's having all the context, I can ask. Yeah. So even though I've not given Bangalore here, it still understands that it's Bangalore and today because of the context that we provided, and it is continuously storing in the same session ID. So there is a complete history of what's being done within the session and so on. Now the challenge here is that it's all great that it's storing every response, every messages that's it's trying to do every tool use. So there is a log of tool use. There is a clear path on all of this. But it's not great in terms of how we could query this, how we could use it like an API, provide an entire context of what the agent did within a session, or store it as a history of messages, or give more insights to while building the agent, right? So to do that, we will be moving it to DynamoDB. Now, in Strands natively provides the support with S3 with few lines of code, but in case of DynamoDB, it requires that we introduce this, we implement the same class that's managing the session, but internally calling the DynamoDB for storing the session and retrieving the session whenever required. So that's an additional piece, but everything else does the same job. So we create a DynamoDB session manager, which will manage all the aspects of the reading the session, writing the session, updating the session, and from there we can see how we could get all this in a more structured format that is queryable, that we could use it for anything and so on, right? So on the DynamoDB, again, it's the same prompt, same tools, same session. Session, except for session manager, everything else is mostly the same. There's no difference between the API calls before and after. So let's move to the one. This is also deployed on the AWS. So we can see here. So we first started with simple call and get the response. Then we checked on what exactly the tool is doing under the hood, which is we started looking at all the event loop and all the events that it's undergoing. The agent is triggering. Then we saw how we can store the context using S3. We are now looking at how we can store the context using DynamoDB. So the same thing is deployed here as well. Let me go to the deployed URL. Yeah. So I'll use the same query again. I'm just keeping this query very similar, given that it's about travel and weather recommendation. Right. So here as well, you can see that we got a session. So let's take a look at this session. Going to DynamoDB, and session was 75 DAC. 75 DAC, right? So we can see here, it's exactly the same what it did in the S3, that it started with the conversation, it created a session. From there, this is message 0, that is what the user had sent. You can see the same message being added here. And then the tool use of the assistant, and then the recommendation from the tool use, right? So it's exactly the same, but the only difference is now is on the DB side, and that opens up more possibility in terms of what we can do with this data and how we could use this data to provide more insights on a workflow that is non-deterministic, driven by agent. So I'll continue with the same patterns of question. How can you provide more details on the Bangalore weather? Right. Okay. Right. So if you had seen earlier, what happened is that because the session was not passed, it was not able to get the date. So so it created a new session with the date. So I did not get that context. So now I'll pass in the session ID, and I'll just ask how many flights are there from Bangalore. So it created a new session. There is no understanding of that. The first question of is there recommend a flight from Delhi to Bangalore. Right now, it should ideally give a response on from where to where, but let's see what it provides. Yeah, so it says now please provide the destination city, because this session is being only continued from the point of Bangalore and weather on today's weather, right? So let me refresh this, get back 6A510. 6A510. So yeah, the first question in the agent when the session was created with only on can you provide more details on Bangalore weather, without the date, without any other context. But now it's maintaining the context. So all I can do is from Bangalore to Delhi. Right. So it's keeping the context, and I'm just reducing the more and more prompts out from here, right? Yeah. So I just provided this prompt, and it's able to give me now the entire the recommendation, because it has stored all these contexts in the background, and it's able to understand from the previous queries that what is the intent of the user and what is the what should be the recommendation for that intent of the user. Yeah. So it gave me that. So let me refresh it and show the entire trail of it. So we see first query was not having Delhi context at all, and the next query it just used weather tool, gave the information. Then the next question that I asked for flights in Delhi to Bangalore, it asked for the date and other things as well, and finally it gave me the recommendation here. So each aspect, each stages is being maintained, and from this we can get more understanding of how the nature of conversation was with the agent, and what was the response, what were the tools used for getting that response and getting that context for the user. and that's how we could, with single file and a simple deployment, creates the entire infrastructure where you have a non-deterministic flow. There's agent, there's context being maintained, and you have everything else in this order, right? There's also possibility that we connect these agents from one lambda to another lambda and create an entire workflow, or use step functions where it could invoke different lambda based on the path, based on the responses from the previous agent, and create that entire workflow. And that's the beauty of this, and that's how easy it is to develop something like where it would take a lot of time in terms of creating more and more this deterministic way of development. Yes, go back. Yeah, so basically we took the user prompt, created an entire workflow built incrementally, that is, start with one simple thing and then add more and more complexity to the same workflow, right? So same intelligent workflow, in the sense what we just saw with the AWS providing all this, the tools necessary to build without having to manage them, without having to have provision a lot of aspects. And serverless gives us capability to try out faster, rather than build the infrastructure, then manage, and then uh, go from there, right? That's all from my side. Here's my details. Please do reach out if there is any follow-up. If there's any questions, do write it in the comments. I'll try to reply them as much as I can, and we'll stay in touch.
Hey, Bharath, thank you so much for that insightful session. I mean, it was more like a demo driven than slides or anything, and that's what I think made it a lot more interesting. So I don't see any questions from the audience as such, but I have a few questions, Bharat. So one is, it can take some time for the LLM to respond, right? So how has your experience been? Choosing the LLM, does it also matter in terms of the response times and everything? What are the various things that one has to take into consideration while choosing? Because Strands gives us the opportunity to choose anything. There's a lot of options available out there. So what are the various parameters or characteristics that you would look at while choosing an LLM?
Right. Many aspects, mostly the capabilities of, and for what it is built for also, right? That provides more context to choose what it should be used for. I mean, there are models that are built for reasoning and thinking, and if you need that sort of a model where it needs to reason and think, let's say for you're building a coding agent which does the coding, so you need to reason and think out all the situations, so those models are better. But if you're looking at more like a conversation, just like a chat where I have a context, and given the context, search and let me know what I should be doing next, right? So there you need more like a conversation. You don't need more of a thinking and reasoning out there. So these are the aspects. But when it also comes to serverless, this it's very event driven. In that sense, you may feel the lag of
Mm.
response, where I've hit the API, the agent is thinking, or it's retrieving the context, but agent do put out the responses at that point of time, that hey, I am retrieving the data, or I am now doing something about it, right? So when it's gateway and when it's all that, it becomes more like a single response and request and response model there. So you could also use lambda URL
Mm.
for streaming that all those events. So then what happens, the user is not have to wait for the final result, but he's still seeing that there is a progress being done by the agent behind the scenes.
Right. Got it. Got it. And you also briefly touched upon step functions as well while you are finishing up. So does step function have like a native integration to Bedrock maybe, or we still need to have Lambda to orchestrate? If you are aware of that piece.
Uh, I think there is the native integration with Bedrock. I may have to check that, but
Okay.
either way, you can use Lambda to orchestrate, or you can. I think you can also use Bedrock agents directly with the step functions. I'll have to check on that. I may not be 100% sure on it.
Got it. Got it. Sure. So Dharmendra,
Also, yeah, I have one question. So, while you are building this agent thing and this LLM part, so means there are other services provided by AWS also similar to what you have built, like Amazon Lex. I remember earlier in my this working experience. So they are similar kind of services where you can build your agent kind of bot, and people can engage with that bot and ask questions, and in the background it was like a similar kind of thing which you have built. So did you also check on those services, like how different it was for you?
Amazon Lex.
Yes.
No, I haven't checked on it. And mostly the workflows that if we are looking at, we need more control over what's happening with the agent within the agent, and get all the events possible from the agent. So, so connecting that's becomes the very core of the entire workflow, because it is non-deterministic. uh, it may not work 100% of the time the same way as a deterministic coding would work, right? So so here, because the Strand gives us that capability of getting to know at exact every event what's happening, we could figure out what happened in that 0.1% of the times where it may not have taken the path that we wanted to take, right? Or that's, I think that's the reason why, mostly we've been exploring on Lambda strands, and understand how more we can get insights from there.
Okay, I have one more question. So, you have integrated DynamoDB. So, like for one session, there are multiple entries in the DynamoDBs, right? So, did you
Yeah.
explore any other service, like because if you go with the high traffic, like let's say 10 people, or traffic increase, so it will is to means create multiple rows in your DynamoDB, right? And suddenly your DynamoDB will be in GBs, or yeah.
Right.
So
Right.
did you explore that part as well, like storing it in different services and then yeah, doing the things?
Yeah, I mean, we could have any other databases also to be used. Postgres is another one where we could make it as make an entry and then have a way where we could manage the data there with partitions and with other aspects there. We could use MongoDB as well, and MongoDB also provides a great capability in terms of vector search and other aspects now. So which helps us, which can help us to manage that growing scale. Right now, this is a very raw example in terms of how the data was being stored, but we could optimize further in terms of the how the tool was called, what exactly to store, or what information not to store as well, so that it could be, the data management can be there in that.
Yeah, awesome. Yeah, that's
one
it from
one
my
more
end. Also.
last question
Yeah.
from myself. So I mean, for someone still pretty new, including me, into all of these agents world and everything, we have this Bedrock agents available on AWS, and then Strands, of course, is the open source version again from AWS, right? If
Right.
in simple terms you would have to explain the difference between the two and when to choose what would you say?
uh, I would say that if you need more control and capabilities in terms of what uh, LLM you want to use,
Mhm.
native or I mean yourself
Mm.
deployed or anything, you use Strands because it gives you that capability there, and it also provides you the options to store in different storage, right? Many there now it's the vector search or the vector the DB search is not just about the messages that was interacted with the agent, but it's also in the context of my original application, like whatever my application is for what I'm building the agent for. So I need to get that context also. So the databases choices may not be that very simple when it comes to Bedrock agents directly. When it comes to Strands, you can have your own database choice. You can have your own customization on it because it gives you that freehand code. Yeah, you create an interface and start interacting with it. So more
Understood.
control, or you want less control with prompt and everything, go with Bedrock, where you don't need elaborate workflow setup. We need elaborate workflow setup. Probably the Strands and Lambda would be the best way, in my
Got
opinion.
it. Perfect. Got it. Got it. Yeah, that's all from my side. Dharmendra, do you have any other questions?
Yeah, one question is coming to my mind. We have Lambda timeouts. After a particular time, it will get timeout. So when you are working with the Strands and Lambda, how do you see that? Like managing sessions with that part and all within that
Yes.
timeout
So
period.
yeah, that's the reason why I think if we use gateway, then it's only 30 seconds, and that may not be enough for a lot of times. That's why using Lambda URL, where it gives you the streaming ability, is also an option to look at, where you could stream for 15 minutes and then still end it. But the other way also is, given that serverless is all about event being driven across different services, you could also think about an elaborate setup of WebSocket, so which then makes everything independent of all the things. Having just the conversation ID and posting the messages based on that conversation ID, you can tie back all the aspects of the agents. So you could have multiple workflow, all disjoint, and events being triggered, and those being streamed back to the WebSocket via the conversation ID, and all can be tied back. So then you're no longer bound by 15 minutes time. Of course, you're bound by, for that one action, you're bound 15 minutes, but overall the entire workflow can run in hours now.
Yeah.
So that'll be truly stateless. Each of
Yes.
them is
Yeah.
independent of each other. Yeah.
Right.
Awesome, awesome. Thank you so much, Bharath. It was a really engaging session with the demo and everything. I'm also just really getting started with this entire agents and all those things. So I got to learn a lot of new things, especially with Strands. I've still been looking at the Bedrock side of things. So thank you so much for the session, and I really appreciate you taking time on a weekend. And thank you so much once again.
Thank you.
Thank you so much.
To
See
learn
you.
from you guys.
Bye.
Thank you.
Thank
Bye.
you. Bye bye.
So yeah, that's it for this month's Serverless Saturdays. We hope you got to learn something new about from the two sessions that we had. The first one, which is of course non AI. That's what something that we tried. We wanted to have something that is core architecture, core implementation, and everything. And we hope you got some insightful sessions on. Video on demand services available on AWS. And on the second one, we had really interesting agents, intelligent workflows. So yeah, look forward to try. I hope that you all try out something new. And with reInvent coming in, we can be sure that there'll be more services that will be launched, and a lot more new services, lot more enhancements, and for AWS folks who are into this stuff, it's like Christmas early, right? Starting the 1st of December. So we will not be having one next month because it's all reinvent, and the bus is going to be there, and then there's the holidays, year end, and everything. We will be back again in January. If anybody of you is interested in presenting, please do reach out to either me or Dharmendra. I'm sure, as I said, there'll be a lot new launches that will probably happen in December, and we'll have new exciting sessions coming up in January and the months after that. So thank you so much, everyone who have joined us once again, and it was really great hosting you. We really look forward to seeing you again in our future months. And once again, if you're interested to present at our Serverless Saturdays, please do reach out to us.
Yeah, thank you so much, and see you next year. Thank you.
Yeah, thank you so much. Bye-bye.
Bye-bye.